said, remove myself. Oh, by the way, no one mentioned my math shirt. Come on. Anyone know who those two people are? Einstein and A squared plus B squared equals Pythagoras fighting over C squared. Love it. Anyway, yep, math shirt Wednesday continued. Today is Wednesday, right? So that would have been embarrassing. Okay, E. Anyone that was in Math 3 Honors, don't raise your hand. Only Math 3 Honors will know that E is actually a number like pi. Pi is for circles. E is for like growth and decay in the natural world. And that's what we live in, I think. Well, maybe not these days. Anyway, that's just a shot at how crazy things are. But E is like 2.718. So I know most students don't know that because we don't do that anymore, like as junior classes, like we used to do in Algebra 2. So I changed it to just 2 to the x because we can think about that and have a conception about what that actually is. All right, and that's not a big deal. Input's it. No, you weren't ready for that, were you? All right, I know, for gosh sakes, we should be able to function as seniors in a high-level math class that we know how to input values for x, output for y, and then graph those points. But then we do have a problem. We don't know all the mathematics that we should. Like, only answer if you know. What's 2 to the 0 power? 3, 2, 1, go. 1. Did you hear your counterparts? This is why I like group responses. You're all supposed to know that that's 1. And I am going to double down on that comment. How can I proceed on if we don't know some basics? And that's where the frustration lies in. Okay, I put a 1 and I put a 2 in. There should not be a problem. 2 to the first is 2. 2 to the second is 4. Now, I have graphed 5 to the x like yesterday, right? If you look at your 9-section sheet there of like all the attributes. The only difference with 5 to the x is it gets a little fat. Like 5 to the second is 25 already. All right, but the same idea occurs that we have this going on as we plug in big numbers to the right. To the left, only answer if you listened yesterday about 5 to the x and you remember negative exponents. When I plug in -1, what is 2 to the negative first? 3, 2, 1, go. Oh, no one said anything. Oh, no. And I actually covered this year. It's not -2. Nobody said that. What happens with the negative exponent rule? What happens to the number? It what? Flip. So 2 to the negative first is 1/2, which is 1/2. So again, knowing these basics that I did cover in Chapter P, the first day when we all freaked out, what is going on in this class? All right, and then 2 to the negative second is actually 1/2 to the second. And then as I plug in bigger and bigger negatives, that's the wrong way to say it, smaller and smaller negatives. -2 smaller than -1. Okay, 1/2, 1/4. Okay, I'm getting annoyed. So what do I draw? Starts with an A. An asymptote. The asymptote is not there. You draw it there to say, okay, I get it. As I plug in more negatives, these fractions get smaller and smaller, almost to the point where they're 0. Okay, so what's the domain? Are there any restrictions on what I can plug in for x? Or can I just raise this to any power I want? The answer is there's no restrictions. Now we go over here. -infinity to infinity. Sorry for my chicken scratch. But now what is the range limited to? What's the first range value that you see there? What number should I put? 3, 2, 1, go. I heard a couple people whispered. They're a little scared though. But look at this. We got to be able to look at the picture and say this doesn't exist here. It starts here is where the y values are covered, not including 0. The point of the asymptote is it never could be 0 as an output value. And then this is what you're filling. And then this really solidifies the last 3 days as well. But also I demand that you know the nature of some of these pictures just by input. Say it again. Output. Is this continuous? Yes or no? There is no interruption. Most of this book is continuous. Most of the book that you see, all the pictures are continuous. Then I guess I'll use this. I think I have, yes, I do, good. Increasing, decrease. What's my hand doing as I read left to right completely? What's it doing? If you have a thing that does only one thing, then circle it. It increases, and it increases from -infinity to +infinity for the x's that I plug in. Is there symmetry? By the way, for the symmetry position, make a note. Look up here because I have a lot of people scratching out. I think they're just doing number one and not listening. That makes me want to go, yeah. All right. For symmetry, we're actually putting even or odd here. So maybe on your little section, what number are those that put the note sheet out from yesterday? What section was that? 7? 8? 7? 7, you should put symmetry there. I don't know if I did do that. Even odd are talking about symmetry with x-axis and y-axis. But does this have any of that symmetry? Yes or no? No. So actually, there's no symmetry. So, but I just wanted to make a note to self for what you do there. Is it bounded? I think this was one of the examples I used for bounded. Yes or no? And it's bounded where? Above or below? There's a boundary below. It's like an electrical fence that the graph can't get past. There are a lot of bounded. Listen to me real quick. A parabola that's going up. Anything that has like a minimum, that's considered bounded below. I asked Westberg. I don't think a calculus teacher is really going to care about this boundedness stuff, but I'll tell you that an x squared is bounded below. Most things have no bounded. Well, I should watch myself. Do you have a change of direction in anything? By the way, extrema is mins or maxes. Someone asked me fifth hour, what's extrema again? Do you have a min or a max? Do you have a change in direction? Do you? Yes or no? No. So a lot of these you can just go ahead and cross those out. They don't apply. There is a horizontal asymptote, and you better write that as an equation. Y equals 0. There is not, though. Don't think there's a vertical asymptote here. Some people think there's a vertical asymptote controlling that behavior. No way. I can keep plugging in these numbers forever for x. So there is no vertical interruption there. And now the end behavior. X finger, Y finger coming up. But let me write the notation. Limit. Let me get a pen first. Limit. Okay, thanks, computer. Limit of f of x as x approaches infinity. When you see this is the same size as this. You know what I mean? That's a subscript that as x approaches infinity. So try to get that writing down correctly. All right, x finger, Y finger. And you can only see this if you look at the screen in my picture. This is why I look at this. Again, I don't understand how students have a problem with this. 1, 2, 2, 4. As I keep increasing the x's, where does my Y finger go? Where does it go? Right to BB8. Anyone notice that BB8 was sitting right there? Anyway, infinity. Nice. And then the limit of x, a limit of f of x as x approaches negative infinity, that equals, well, let's hold on here. X finger, Y finger. -1, half, -2, a fourth. As I keep plugging in these values, where is Y approaching? What number? 0. And that's the big deal there. That's the big difference. Some of these have unique answers when you do these limits. Okay, so now I don't want to show the graphs. I'm going to scan through some, but look at page 1. And I thought I had a book, but I think I threw out that one that I had. Page 1's just, page 1, you're good. Do you mind if I use yours? I'm sorry. So page 1, you're good. You should be able to grab. I need points though. So show a chart of values. You plug in 1, what do you get for Y? 1. You plug in -1, what do you get for Y? -1. That's why that's easy to graph. Do that in interval notation as well. Page 2, come on, x squared, you can do that. Page 3, x cubed, we've done that a million times in class. Input, say it. I've actually done it in class. I've literally inputted and outputted. Page 4, I guess I'll go here so you see this. Square root, you got to be kidding me. I've graphed square root like every other day in here. What's the first x value that you can plug in? Start with a z. I don't have time for this. 0. You can't plug in negatives because you can't take the square root of a negative. And then I think you put yours out of order as well. I think you, what's your next one after this? Isn't it a absolute value? Okay, anyway. Absolute value of x. What's the absolute value of -1? Input? Output. I just gave you that. What's this absolute value of 1? Don't be silly on this. 1. Some people try to do opposites on that. Input, output, you'll see what that picture is. 1 over x, I've almost done that every single day in here. Okay, there are asymptotes. What's your next one? 2 to the x? Did we just do that one? Right? I think we're through how many? Was that 7 or 8? Those are all very doable. Those are the key components of graphs that you should know, like what you expect the picture to look like. And that's why we're going through the input-output here. What's the next page? Sine. Don't I have a picture for that?
Yeah.
From that picture, you should be able to fill out the chart. You got it? I will say this, sine goes like this. It's like a heartbeat. Sine's like a heartbeat. It goes up, down, up, down, up, down. That arrow just means the pattern continues. Is it bounded? Yes or no? Yes, that was the whole definition of bounded. That tells you that there's a range issue as well. What about next one? Cosine? Right? Cosine?
Yeah.
Okay, so that, you went in the wrong page of that one too. This, because you stapled wrong, it was the wrong one. All right, so cosine, same thing. And then, by the way, sine and cosine do have symmetry. You need to look at it and figure out what symmetry they have. Okay? What's next? Don't do greatest integer. We'll just cut our losses on that. It's just a really screwy function. I may show you greatest integer tomorrow. What's next after that? Huh? Didn't I draw that picture? Okay, so I drew that picture for you. I know you did this last year in graph logarithms, but we're going to do it in chapter 3 a lot. So what am I showing that a natural log or a logarithm has? What kind of asymptote? Vertical. From that picture, you should be able to fill out the chart fine. All right, and then what's the last one? Didn't I show you logistic yesterday as one of my examples for bounded?
Yeah.
But now you can look at that picture and probably fill out the chart pretty good. So the chart, not all the things apply. If they don't apply, just cross them off. All right? Because some of the things don't apply to a particular picture. You got it? Okay, so that's what I want you to do the rest of the way, and I do expect you to have this done tomorrow. I'm collecting your book. Alrighty then. And then you feel free to work with someone on that, or